Hello children, how are you all? I hope you all are fine. Now here in this video I am going to explain you about the comparative study between the solid, liquid and the gases. That means how they are different from each other. Okay, in terms of the molecular arrangement and other dimensions will be also discussed here. Now here you can see in the picture it is given over here the comparative study of characteristic of solid, liquid and the gases. Now here the characteristics has been shown. Then solids, what are the characteristic of this dimensions are there, okay, liquid and the gases. So one by one I am going to explain you. Now when we talk about the arrangement of particles, particles means what? The molecules, okay. So in case of solid you can see that the molecules are closely packed. That means there will be no gap in between. Okay, in between whom? In between the molecules. So the intermolecular space will be less. That's why they all are closely packed. Whereas when we talk about liquid, they are the loosely packed ones. Okay, the molecules are having the space in between. Intermolecular space will increase in comparison to the solids. But when we talk about the gases, the molecules are very far apart. That means intermolecular space will be more, or you can say the maximum one. So though these both characteristics, we have seen that arrangement of the particles and space between the particles. So on the basis of this space, the situation here is what? Arrangement of particles. Because the space is minimum, that's why they are very closely packed. Space is more, then loosely packed, and space is maximum, then it will be far apart. The molecules will be far apart. Now keeping this in your mind about the space, obviously when the space is less, then the force of attraction will be also considered. Okay, so force of attraction where? In between the molecules. So this force of attraction in between the molecules in the solids are very strong. Okay, since they are very close. Then less strong because there is some space in between the molecules, and very weak because the molecules are far apart. Now the next dimension, that is the movement of the atoms, moving of the atoms. So either the molecules or the atoms, how they are moving inside this solid or the liquid or the gases. So it is here when we talk about the solids, they vibrate at their positions. Who vibrate at their position? The atoms. Okay, what happens? The atoms in the molecules, they will vibrate at their own positions, whereas in liquid you can see that there will be continuous motion, and in gases the motion will be random. Motion means the movement. Okay, so that's why you can see this, on the basis of this, the movement of atoms or the molecules, they vibrate, and that's why they are not changing their shape. Okay, they will remain as it is. Whereas when you see about the movement of this continuous in liquid, so what happens? But within the boundary, the molecules or the atoms will move within the boundary, and that's why their shape is indefinite. Okay, they got the boundary and then in between. Whereas when we talk about the gases, so there will be the random motion, and that's why their volume and shape both will be indefinite. Okay, here just because only the vibration is there, that's why volume is definite, and here continuous motion, but the boundary is there, that's why their shape will be changing, but the volume will be the definite one. Whereas in this case, because of the random motion of the molecules or the atoms, the gases will be of indefinite volume and indefinite shape. So each and every dimension is dependent on each other. Okay, it's not like that every dimension is having a different feature. No, but they are dependent on each other. And the next last comparison is shown here, that is the compressibility. Okay, compressibility, that means applying pressure on it and making it compressed. Okay, so solids are not compressed and liquids are slightly compressed, since because Again, the another dimension is also here, that is the intermolecular space. If the space is not there, so there will be no compression. Okay, it will not be compressed, and when there will be the space in between the molecules, they will be slightly compressed, and when there will be maximum space, then it will be highly compressible. That means there is a chance of applying pressure and bringing the molecules close by. Okay. Now, still if you are unable to understand this, I am going to explain you with one more example of your day-to-day life, that about the school. Okay, just imagine yourself, you are in the school, or you remember also when you were in the school, there were three stages, or you can say the situations. Okay, so one by one I will explain you. First situation, number one situation is what? When you are inside the class. Okay, inside the class you are having your particular seat and you are sitting on your places. Okay, you are not allowed to move here and there in the class. Okay, though you are present inside your class. So that situation is just similar to the solid state. Okay, how? Because you are acting as a molecule. Okay, and you, as you all are sitting on your places very closely packed. Okay, space is minimum in between you. Force of attraction, that means as you are close by, so the force will be very strong. Then you can move on your places. Okay, just like to take out your book, to open your books, to take out your pencil, to open your pencil box, like that. Okay, so that is the solid state. Okay, now second is the liquid state. Okay, liquid state is just similar when the bell rings of the another period. Okay, so during that time what you do? Do you remember what you do? You used to move from your places, but you are not allowed to go out from the class. Okay, outside from the class. Okay, so here that is the liquid state. You are able to move. Similarly, the molecules are also able to move, but they will move within their boundary. Okay, wherever they are kept, they will move inside it. Okay, that's why liquids are able to flow. So here you are just similar, you are showing the similar condition just like liquid molecules show. Okay, you are able to move from one place to another, but you cannot go out of the class. Okay, and here comes the third stage, that is, can you guess that? Okay, fine, I'm going to tell you that when you are during the recess time in the school. Okay, what is the position? What do? You used to run out of the class and you are allowed to move. Okay, so you are just running towards the canteen, you are going to take the tiffin, you want to cover that area where every day you are going and having your meal over there. Okay, so one class students can be spread in any of the corner of the school. So that is just similar to the gaseous state. The molecules are allowed to move in that space, in the given space. Here for you the given space is what? The whole school. In every corner you are present, you are allowed, you can go anywhere. So that is the gaseous state. So I think you all have understood about the comparative study. Now some more features, or you can say the another topic, the change of state, I am going to explain you. Now here there is the change of state. Okay, simply by giving the energy, by losing the energy, they can change the state. How? When you see, when you are increasing, here's the ice, water and steam. These are the three states of matter. Okay, or you can say the water. Okay, so here you can see that how they change the state. Okay, from one state to another state. Here, when ice changes into water, that process is called melting. So solid changes into liquid state. How? Because when you are increasing the temperature. Again, if you will keep on increasing the temperature, the water will turn into the steam. That is it will attain the gaseous state, and that stage is called that process is called the evaporation. Okay, now here again the gases can be changed into the liquid state. That means the steam can be collected as a water through the process of condensation. okay, when you will decrease the temperature, okay. And similarly, water can change into ice, that means the liquid state can change into ice by the process called the freezing, when you are decreasing the temperature up to freezing. So these are the four processes which are involved in the changes of state: melting, evaporation, condensation and freezing, okay. So students, hope you all have understood the topics. If you have any doubt or question, you can ask in the comment section below. Please like, share it with your classmates, subscribe, and don't forget to hit the bell icon so that you can get my latest updates. Thank you and take care.